Okay, this is part 2 of our two-part series on the derivative of sinusoidal functions. In the first part, you noted that graphically we were able to establish that the derivative of the sine function was the cosine function. So both function and derivative were graphed on the same set of axes. And then we looked at a proof from first principles that showed the same thing. The difference there versus what we had done with polynomial functions is that there were actually two expressions or two limits that you had never seen and or evaluated before, which was cos h minus 1 over h and sine h over h as h approaches 0. So those two limits were proven by different methods, and you can find them online. The squeeze theorem proves sine h over h, and then there's another form of proof involving Pythagorean identity, as well as one or two other tricks to prove the limit as h approaches 0 of cos h minus 1 over h is equal to 0. So in this segment, we're going to look at the derivative of the cosine function with respect to x, and we'd like to know exactly what that is. So we're not going to do this from a first principles perspective. In fact, there is a much more efficient way of doing this. Not to say that we can't. Maybe an extension or something you would want to look at or consider puttering with, following this particular video. So in order for us to do this, if we were to let y be equal to the cosine of x, I also want you to remember that proofs of other concepts or proofs of other proofs are conducted or completed using previous knowledge. Okay, so for instance, we know that the cosine of x is equivalent to pi by 2 minus x. This is a known fact. So also take note that we do have a derivative for the sine function. So that means we could perform a substitution. In fact, when we go to write the derivative of the cosine function, okay, what we're going to do is the following. Okay, where we see, okay, sine, recall that we're going to take the derivative of this, the sine of pi over 2 minus x, with respect to x, because that's exactly what cosine is equal to. So when we move forward on this, the derivative of sine is cosine. So we'd have the cosine of the angle. But also remember that this particular portion here, this is the argument of the angle, or, okay, this is like the inner function. And with the inner function, we need to apply the chain rule. So what does the chain rule tell us there? So we're going to take the derivative, right? So we're going to multiply that by the derivative of pi over 2 minus x with respect to x. So let's follow through on this. So what that's going to give us is minus 1. Okay, because of the fact that pi over 2 is a constant and the derivative of a constant is 0. So what we have now is the minus of cosine pi over 2 minus x, okay, which is also equivalent to, okay, wait for it, because here it comes, is that the cosine of pi over 2 minus x is also equal to the sine of x, right? Because there is also a little known fact that the sine of x is equal to the cosine of pi over 2 minus x. So therefore, we have just proven using a cofunction identity that the derivative of the cosine function with respect to x is minus sine x. Okay, so what we'll do now is let's apply this to a single example, and when you come back into class tomorrow, we can pick this up and you can carry forward in determining derivatives. So let's try this one out. Let's do, for example, y equals pi multiplied by the cosine of x plus 2x plus 2 pi sine x. What I want you to take note of in this example is that, I'm just going to label them with a capital C. Pi is a constant, okay? 2 pi, all of that, constant, okay? Of course, 2, that constant multiplier. So when we find our derivatives, right, understandably, if pi is a constant, if you're to apply the product rule, and we'll do it once, we won't have to do it again, but the derivative of that would be 0 times the cosine of x plus second term, or sorry, plus the first term, pi, times the derivative of cos x, which is minus sine x. So that all relates to the first term, okay? Derivative of 2x is plus 2, and of the final term, if we were to apply the same reasoning and or rule, we can eliminate the bother or the worry of doing such derivative finding using the product rule, and we'll simply focus on applying this type of reasoning to this term here. So at the end of the day, we're going to end up with plus 2 pi times the derivative of sine x, which is the cosine of x. We have just successfully found the derivative, so let's finish this off. This term is nothing more than 0. Here we will have negative pi sine x plus 2 pi cos x. We'll just rearrange the terms a little bit. So we'll have minus pi sine x plus 2 pi cos x plus 2.